Hello and welcome to Engineering Physics for A06. This is going to be an overview of the design and synthesis project that you do as your capstone in ENGPHYS. So this is a capstone project, one of the things required for engineering accreditation, and the engineering physics one has you apply your undergrad ENGPHYS knowledge to select a meaningful real-world problem and engineer a solution to it by mathematically modeling the impact of design decisions and then implementing them physically as part of an engineering team. This requires you to be in the final level of an engineering physics program other than the biomed program because they have a separate capstone. This is me. You can contact me there, but the best way to get in contact with me, especially this year, is via the course forum on Microsoft Teams. We also have a lab technician, Peter, and you can contact Peter via the forum as well, or perhaps via email. We'll have updates if he prefers the forum on the forum. Okay, the forum again, Microsoft Teams. If you're not in this, then please send me an email and I can add you. Okay, here's what we'd like you to get out of the course. By the end of 4A06, you'll ideally be able to link your undergrad theoretical knowledge to the real world and apply it to conceive, design, implement, and operate a physical device using an engineering design process, including finding a real-world problem and conceiving of a solution to it, as well as the specs that that solution would require, then designing it using mathematical and physical modeling, engineering design principles, implementing it through iterations and rigorous testing, and then operating a device that solves the problem at these required specifications. Besides that, we want you to work effectively in an engineering teamwork environment, including demonstrating commitment to your team's objectives through punctuality, attendance, accountability, and positive engagement with the project, completing individual and team deliverables within both external and internal time constraints, giving constructive team member feedback, using team member feedback about yourself to improve, and fostering a healthy working environment with your team. And finally, communicate information about your inventions in a modern engineering world, including in technical reports, in technical seminars, trade show formats, social media, and to yourself and a mentor via reflection on personal performance and skill development. Now, a lot of this stuff is going to be happening in video format this year, but this just brings us more into the modern engineering world with how we're going to be communicating these designs. Another thing to say here is that 4A is different than a lot of other courses that you've had. In other courses, if you aren't told that you need to be responsible for something, then usually you don't need to know it. It's kind of the course's responsibility to tell you what you need to know. In the real world, this is definitely not the case. It probably hasn't been the case in a lot of courses you've taken already as it is, but here in Capstone, it especially is not the case. Your goal, what's going to bring you the most success here and in life, is not to kind of wait around for other people to tell you what you need to do, but to become a person who takes pride in knowing things and takes the initiative to learn things even when no one tells you to. Kind of realize when you need to seek external information and then have the right attitude to go out and get that in order to succeed. The most successful people that I know in ENGPHYS have leveraged the problem solving that kind of comes from having this strong physics background education to then go off and use it to kind of learn to love learning and problem solve by being willing to seek this information and master whatever subject you need to, whatever topic you need to, whatever area you need to, in order to solve whatever problem you're interested in solving. And it starts with this attitude, with this initiative. So right now for yourself, say, I take responsibility, and you're going to be much more successful. For materials and fees, they're very project specific. And remember, the project is up to you. For standard projects, like this is the regular group that doesn't have any external funding, the only funding available to you will be the default funding that the department gives to all groups of $650 per group of 4. If you have less people, it'll be scaled accordingly. If you're taking advantage of this funding, or I should say, in order to take advantage of this funding, you need to keep receipts and keep in mind that you're only going to be reimbursed in April, unfortunately, not in December as well. If you do get external funding by winning design competitions or being personally wealthy or having a client that is able to pay for the project because you're developing it for them, then that doesn't take away from this funding. You can still take advantage of this. Now, if your client is reimbursing things, then you can only get reimbursed for the same piece of thing once. So if you get reimbursed by the client, then you don't need to take advantage of this. This is in case you are being reimbursed for something somewhere else, and it's not enough to cover the full thing, then you can take advantage of this reimbursement as well. Or maybe this is your entire funding. It's possible to do an entire capstone project on this, depending on the size and scope of the project that you select. A lot of past projects have been way more ambitious than this, but that's not actually required. Capstone this year is going to be in an entirely remote learning format. You're going to work as an engineering consulting team of 3 to 5, ideally 4 people, with your classmates on a project of your choosing that satisfies some client's need. Now, the client could be a real professor looking for equipment or tools for their research lab, an industry member, a community member, or a hypothetical client. Like if you don't have a real one, then I'm just going to act like your client for you. Students will complete the project proposals and design work approved by the client. So you come up with this proposal that meets the thing that they're looking for, and then you get them as part of the project to communicate with you on a regular basis and agree that what you're proposing to do is going to satisfy the thing that they're looking for. Following project proposal and design work approval, the client's contractor, which could be an external fabrication facility or our lab tech or other MAC technical staff, or even yourselves if you like and are able to do that, will help create and test the prototype. This involves you working on and submitting assembly and manufacturing instructions and documenting and commenting on the fabrication of the device, followed by documenting the testing and the path for future improvements. Finally, once you've done all of these things, how do you present it? Well, you're going to turn it into a final report and video presentation to be delivered to independent industry judges at the final expo. In many cases, the judges are shared across engineering departments, so the same person who evaluates computing and software or electrical and computer engineering projects would evaluate your projects and judge them by the same benchmarks. So don't think of this as being in competition with your fellow students in the same program. Think of it as either being in competition with yourself to do the best that you can do in this course, or being in competition with other departments or schools. To look at the end of the course, there's 5 different parts of project deliverables that you're going to need to hand in. There's the project proposal, there's the engineering design work or mathematical modeling, there's the assembly or manufacturing instructions, the testing, and finally the Expo deliverables. So let's go over these in brief. The project proposal is a number of things together. This sets what it is that your goals are for the course, what it's for, what you're trying to do with your project. There's a few sections. The problem statement, and these sections kind of build on each other. So you really need this first one to be nailed down and clear before you can go on to the second one. A lot of the time people try and do them backwards, but they should kind of lead to the next, to the next, to the next. So one of the things we're going to look for when we read your general solution description is, does it match what you said was the problem that you're going for? Okay, so problem statement. This is go from a general aspect provided by the owner or the client to a specific aspect that the group is going to focus on. And what I mean by this is what really is the big picture thing that they're trying to do? What is the client's challenge with this thing? What's the underlying issue that they're trying to solve? And then zero in on the specific part of it that needs addressing by you. So maybe this is something like, we need more we need more global energy to be generated efficiently, and one of the ways that we do this is with solar cells, and one type of solar cell is this particular kind of solar cell, and one of the challenges in manufacturing it is that this phase of the process has poor reliability or uses too much energy itself, and now you've narrowed down to one particular part of it that shows what it is that we need a solution to. This is one of those things that's obvious in retrospect, but the reason you want to know the general context of the thing that your device or project is ultimately trying to solve is to help you make value judgments of what's important and what isn't. Sometimes it's going to be obvious, but especially if you have a hypothetical client, it's important to pin down what you're going to be doing and what it really is for, why they want it, so that we know whether or not your solution makes sense. So in that solar cell example, if the way that you improve the manufacturing process involves blocking out the sun that then makes the whole original thing kind of pointless, then this is not going to be a good solution, right? But we need to know what that original thing is to know whether or not this is a good solution for the problem that you've proposed. Next up, the general solution description. What this means is you describe what a solution to this particular problem would look like. Come up with some kind of a way to evaluate alternatives, ideally with a merit function, some formula to decide what's good and what's not. It specifies the criteria that this solution would need, and quantify desired solution characteristics. Then when you write your merit function, check that it satisfies edge cases, scaling, and reality checks. So what this means is edge cases, you put in a brick, right? Like imagine that the thing that you end up delivering is a brick. It should fail the merit function, right? It should not be a solution. The null solution, whatever you want to call it, maybe handing in a brick, handing in nothing, should not be better than what you're hoping to hand in later when you propose your solution. Scaling means check that the priorities are right in this merit function, right? If you say that the device scores twice as good if it uses 10% less power, is that really important given the thing that this is supposed to be a problem solution to, right? So check that the way that things go into this scaling and the merit function makes sense. And then finally, reality checks. This means see if not just the way that things get better or the proportionality or the edge cases, but just overall, does this function kind of represent the solution? Is this going to, is the thing that you're going to be eventually, if something does satisfy this merit function, does that mean that it is a good solution? If not, then you need some other things incorporated into that as sort of to make sure that this function is real. This idea of a merit function can do a lot of heavy lifting to clarify what the real goals of the project are. It is going to be easier to come up with a description for what the project should be if you have a very clear problem statement. And then once you've got that, you can come up with this way to prioritize between cost, between ease of manufacturability, safety, reliability, all of these different factors. They matter to different degrees. They all matter, but you're going to have to make choices in your optimizations. Part of doing engineering is making these choices. And if you can at the front end specify your problem so that it clarifies where the relative values of these choices lie, then this can help you do the engineering later on. Next, you're going to want to explain some existing solutions, if there are any, and how they rank up in the merit function. So if you're doing something that there are some solutions to, potentially, quote unquote solutions, then what is it about their score in your particular merit function which you perhaps get to decide on or clarify with your client, right? Then where are the existing solutions? What do they rank as in this merit function? And the important part about doing this is that then you're going to propose the specs for what you would like your device to do, and it hopefully will do better in the merit function. If it doesn't, then it's pretty disheartening. It means you've got to go back to the drawing board and perhaps come up with a different problem that you're looking for, or propose something more ambitious as a solution, because if it doesn't look better from the priorities that your client would want for this particular project than the existing solutions, or perhaps the null cases, then it means there might be some problem with your merit function or a problem with your proposed solution, in that it's not actually going to be better than what we have right now for your client. So this is something we've got to address right at the start. Anyway, assuming that it is actually an improvement, given the general solution description and the existing solutions, then we're in good shape and we can go on. One thing that also shows up in this proposed project solution and its specs is you have to clarify this, like really have in mind what the final thing will look like. You're not held to any of this, right? Like you can change the details that are in here later. Just keep in mind why you came up with them and what the motivation behind them was, because that will tell you, it will notify you if one of the changes you make later, we're actually at risk of going outside of the range where our solution has a purpose. Yeah. So you propose it at this stage, again, while keeping in mind that you could change it, down to the level of what the operating instructions are going to look like from the end user's perspective. The specs here should be something that could be observed by the client, right? The things that you would plug into the merit function should be things that are observed by the client. So if it's some internal specification like, oh, the code that's running this has only 40 lines, that's not a good spec to put in here, because that's not something that your client would be able to observe at the end of it, right? It gets the whole task done in 30 seconds while only using this much energy and costing this much of supplies to do it. That's a thing that they could observe. So these are the kinds of things you would have in the specs. And perhaps the most important part of the project proposal is to clarify what kind of engineering design work you see yourself doing. And this is down at the individual level, like who is going, what aspect is each team member going to tackle in this project? And in particular, what kind of mathematical modeling / engineering work, which we'll talk about in the next section, is each member of the team going to do? This needs clear boundaries between people. And one of the most important things is is that the work balance is about equal for each team member. You need clear specs for the information that's passed from one aspect of the project to the next. And you can clarify this at the start to allow people to go off more or less independently and work on their own engineering design without having to wait for the other people to do their work. If at the start of the year, one group member can't do anything until another group member does 2 months worth of work, that's a bad project. We need a different way to break up the work in this plan so that we can make progress and go on. Everybody needs something to do, and there has to be clear boundaries for this defined at the beginning so that team members can go off and do their engineering. Now, I say next that it needs owner approval. So when I came up with this at first, I guess I was thinking of construction. In construction, the owner is the client. So wherever you see owner in this, just interpret it as client. You need the client approval that makes that this whole thing makes sense and is what they're looking for in their solution. And it also needs course admin approval. So even if you have an external client, you need your TA and me to say, yes, this looks like a good thing to go for. This looks like a good project. Now, we might reject it for a variety of reasons. I don't want to say that this is it, because creative groups could come up with new things that technically meet the rest of these, that don't get rejected on these reasons, but may be rejected for a different thing. Anyway, here's the reasons why we might reject it. The work breakdown is unfair and doesn't give enough design responsibility to each team member, like we were talking about there. The project description is too vague. This happens all the time. So be as clear as possible with all kinds of aspects of this. Kind of question, say like, what does this mean? What is that? What's this word? The project has major safety issues. It's not worth it, right? Like if you don't need to pick something that's super dangerous. And finally, the project's infeasible given the time frame and the budget available. There are some ambitious things that you can do that are doable in the time that we have. And then there are all kinds of other bigger things that you would like to do that just are not doable in the basically 6 months that we have to work on this and the money that's available for reimbursing these projects. If you want to do something that's even more impressive than that, one of the ways to tackle it is to make the project sort of like phase 1 of this bigger initiative and work on delivering this one aspect of it, which would then lead to a larger solution down the road when combined with other people's work. Maybe that'll be you in an entrepreneurship setting. Maybe it'll be the rest of a research group if you're working for a professor, for example. Or maybe it'll be the first step of a capstone project used next year. Okay, major part 2. That all settles what the project proposal is. Very important to get that hammered out very well. And there is a bunch of almost spec determining, not quite design work, but scoping out the limits of what design work you're going to do and what the point of the design work is and what would make its results good or bad. That all goes into the project proposal. Again, you really need the first part to be clear before you can go on to the second part, because we're going to be checking that this actually does match the problem that you laid out here, and that these are clarified against the merit function you put in the general solution, and that your solution would really satisfy what we're looking for, given what we laid out in these earlier things. So they kind of go one to the next, to the next, to the next. You really need all of these done in sequence. So mathematical modeling or engineering design work, this is, again, individual. There's separate sections needed for each team member. Like we need each team member to submit their own engineering design work. And the contents of this would be a literature review, the mathematical modeling, which is analyzing how things work and drawing conclusions. This is like it doesn't mean that you used a bunch of trig or something or did like a Fourier transform. It just means in general, you used physics, right? You took some real world situation, you transformed it into some kind of a math domain, you solved it, and then you went back. It could mean a bunch of simple math and like a lot more on the physics and modeling side. It could mean that you're doing finite element method or something, or like a heavy computational simulation type thing, but it's not required. It's just modeling what's going on in the real world. This involves, at some point, making engineering design decisions. One way to think of it is justify everything, even if you chose the default. Explain why that's appropriate, right? Optimize. This is what's helping to make it engineering. This can aid you can aid your work, so this can be aided, I should say, with simulation results to make these decisions. But one thing that's maybe more important is to mention that reality is the ultimate judge here. So in the past, people have used a simulation or used an analytical calculation where they had to make so many assumptions to make this work that they don't believe their own simulation results. And they thought, okay, I'm just going to do this thing and hand it in, but I don't think it's actually right. I'm just putting it in because Minix said that I need mathematical modeling. No, that's pointless. You don't get any points for that, right? Only do it if you can do it in a way that helps you out. So and I realize that sometimes it's very difficult to model things. If you've already built the thing, it's hard to get help from this model. So definitely you're going to want to do this design work ahead of time. Imagine you didn't spec out the pump very well. You just kind of bought this pump. Fine. Okay. What could you do? You could calibrate it. Well, one way to calibrate it is with kind of an experiment to see how much water goes through for certain pump settings. And there's a lot of calculations around this. There's like hose diameter things. There's various fluids things that would go into that. There's all kinds of complications, but you could balance it, right? You could start off by saying, here's roughly the model that I think it will work on the basis of. And now we do some tests and fill out this table. And then this justifies what's going on in the model. And therefore I can fit to it and come up with a calibration curve. So that's still mathematical modeling. You used some physics to say how you think it's going to work. And then you've gone and done some experimental work in gathering data and doing this calibration. By being scientific about it, that can still be some mathematical modeling. It's still engineering design work to do it that way. That is way better than assuming that the pump is a sphere and using some fake convection equation to anticipate what the heat transfer will be that has so many assumptions and made up things in it that you don't believe your own answer. That's pointless. Don't do that. That's not the goal of this. This is not just to do something that looks impressive. This is to really use whatever mathematical modeling you can and is appropriate to help you make design decisions. So there's a big space of what would be acceptable here. One thing that's important is that before your team can progress and before your team members can pass, every team member needs to get an okay that yes, they have done enough mathematical modeling. There's a certain benchmark which is a little bit hard to quantify in words, but we'll give you as much help as we can throughout the course. You'll see that you can hand things in multiple times and hear feedback on whether or not it's at the right level. Will help you make it better. This has to be done by every person in order to pass. This is a huge accreditation thing. This is where you show, yes, you have learned how to do engineering throughout this degree. You're capable of it, and we're okay with giving you a degree at the end of it. Okay, the next big part of the project deliverables are the assembly instructions or the manufacturing instructions. This really, what goes in here depends on your particular project. This is everything that you would expect a fabrication plant, like imagine you're going to mass produce your project. This is everything they would need, all the instructions that is, they would need in order to do that. So this would be the result. It might be mechanical drawings along with a set of steps. It could be like IKEA style instructions for how to put together the parts that you bought. For anything you intend them to buy, you would say, here, get this thing, this thing, this thing, along with suppliers and the parts number that they would use. So it contains a parts list. If it's something that they need to make, we'll talk on the forum about what things are needed by like the 3D printer, the laser cutter, etc. Whatever files would be put into those need to be in here. Anything that you would want to hand over to Peter to make it as easy as possible for him to actually build this goes into the assembly instructions. And also the code. So whatever code is up is loaded onto your, let's say you're using a Raspberry Pi or you're using an Arduino, whatever code is loaded onto that and instructions for doing that would go into this as well. The contractor, so Peter probably, evaluates and gives feedback and asks questions. This is before they actually go and build it. They are going to take the set of instructions you put in your assembly instructions and look it over, ask questions, give you feedback and suggestions on how you could make it better. You know, like if Peter has a huge amount of experience with this, and he can probably find different ways that you might consider doing 3D prints in order to make things work a fair bit better. In machine shops, if you manage to get into a machine shop while you're going through this and are going to be machining parts, groups in the past have said that experience, like talking to the people that do the machining and hearing from a machining perspective, or even just thinking about it from a machining perspective, made them go back and redesign how they were planning the device to work, because they realized actually the thing that they had before was going to be way more difficult to manufacture than this slightly changed version, which achieves the goals just as well, but now has this other advantage of being possible to build. All right, next part is testing. So this is the set of instructions for somebody, the contractor, likely Peter again, to carry out in order to test your device. So the contractor is going to carry out these tests and provide feedback and give results for how it works. So I didn't mention earlier, throughout the assembly, Peter is going to wear like a GoPro and give you a video of building this device, then show you what it looks like after it was put together, how the assembly ended up happening once it is built. So you hand in the instructions, and then after that, Peter goes and builds it, and we'll show you what it looks like while it's being built. Now you have this in order to maybe make adjustments. There's limited opportunities to say, ooh, it looks like that part didn't work. Can we adjust this thing? Then we can carry out the testing. And the testing, along with so you give a plan and instructions, Peter will carry it out, wearing, again, the GoPro, perhaps discussing with you in real time, a limited number of times to say, hey, here's this test that's happening. What should I do now? What should I do now? The plan is laid out ahead of time, but there might be instantaneous adjustments to this that you would make in real time. So contractor provides the results, and after that, you give a reflection on the test results and a path forward, anything that needs to be changed in light of how the fabrication worked and the results of the test. Then you can give a second phase of debugging instructions or edits or maybe rebuild instructions and new tests. Peter will carry these out and give results as well. Now, it's not so important that, especially compared to previous years, that the device actually works. You're going to be judged on the engineering that you put into coming up with a really clear and sensible project proposal, coming up with good engineering design work, which is now expanded in a big way. This is given more time in the front end, clearly specifying your assembly instructions and going back and forth to make sure that it's really good before it gets built. Then documenting what the testing should be, how it worked, what worked what didn't, and commenting on it and reflecting on it and giving a path forward. This is where the marks come from, and this is what the expectation is for the tasks, not necessarily getting it to work, and certainly not just smashing your head onto it and spending tons and tons of undocumented hours tinkering to make it work. No, we're doing the systematic engineering approach. It's arguably what we should have been doing all along in past years, and hopefully this is a benefit of this change in course structure that leads to something positive. All right, finally the Expo. In this, the Expo is a number of things. So first you prepare a final report that collects all these deliverables and write-ups into a single document, and then create a video presentation that is sort of a short form, maximum 5 minutes, that explains the device's intent, all of the engineering that you put into it, kind of overviews it, shows off the plans to put it together briefly, and then the results of building and testing it. So this all goes into the video presentation, the engineering, the current performance, and the future improvements. Then industry judges will view the video, they'll have access to the report to look at, and you can draw their attention to any other things that you'd like. I think all the stuff you'd want to draw their attention to would be covered in the report somewhere that summarizes the rest of these things. Anyway, then they have an opportunity to meet with your team, ask you questions, and give you a rating. Using the same format, we're using the same format for the Expo as the rest of engineering, and in some cases, common judges. So each document needs to be approved as like a team thing before you can move on to the next one. This is this needs to be approved or approved with minor revisions. That means like, okay, basically it's good. We'd still like you to change this, but you're at a point where it's good enough that you can start seriously as a team moving on to the next stage. This needs to be approved by the client and the contractor for steps 3 and 4. Well, really step 3 needs to be approved mostly by the contractor. Okay, now you still need to have these step 3, this step approved by by your TA and your client. And the first part needs to be approved by your TA and your client, and also me. So make sure that you've checked in with me if I'm not your client for the project before you go on to the next one. Now, in addition to that, you're going to be handing in drafts of updates to the individual parts that you're doing weekly. So looking at the project schedule, you see here that Friday the 11th is when the group selection is due. This is in a forum post, and we've also got the homework due. This is a survey. There's 3 reflection surveys, one at the beginning, one at the middle, which is here, right after the winter break, survey 2, and then survey 3 is due right at the very end. So 3 surveys are due. Besides that, there's 3 things due every week. So there's a draft, and the draft means a draft of your next section, your next kind of bit of progress towards these main project deliverables, whatever it is that you're working on. Then a review of somebody else's draft, which is perhaps going to be somebody in your group, but most of the time, if not all the time, not somebody that's in your group. You're going to be paired up with them every week. It's going to be somebody different, and they're going to review your draft, you review their draft. And then on Friday, you submit a project status report. So we'll go over what that means, but this part alternates. So every 2 weeks, you submit a project status report. Every alternate 2 weeks, you submit something from ITP metrics. This is a peer assessment. So the little bits of deliverables all along the way are pushing you towards success on the project. So the general version of the timeline is what's laid out in these little sections beside the deliverable descriptions up there, and what's in in this column here, rough project target. This is very broad, and you ideally want to make something that's specific for your team. So some projects will have very extensive assembly instructions, and we'll want to leave a lot of time to do that. Other projects, if they're not very difficult to build, so it's mostly just putting together pieces and not a lot of machining, then that could be something that's not very extensive in the assembly instructions and would have this part take a lot less time. Up to you. So depending on what your particular project is like, you would have variations on this timeline. Note that you don't want to leave big things till the very end. Even though the video is not technically going to be marked until the end of the whole course, you can make a video that covers the project proposal, like the first parts of the video, and submit this. And then getting feedback on that early will allow you, like by using it as one of the draft things that you put together, will allow you to fix things that are issues with this. By far the best videos are ones that were often really bad in the first submission, and we were able to point out, can you fix this, do this sound editing, this part needs to go. Then the videos got a lot better later. So these are things that you want to submit early when you can. Okay. So generally you want your project finalized at the beginning of October, but things can vary. You might have it finalized earlier. This is the project proposal, that is. Like finalize what project you're going to be working on. But you might have it finalized later if it's important. Now, it is important to get this right, so don't worry if it's taking a little bit longer than this target deadline. More important to really get it right. Okay. Then the design, you're going to be finalizing it throughout November and start working on assembly instructions perhaps into the start of the break. Then assembly instructions finished in January so that you can then get it assembled and start working on the testing. Iterate. There we go. Iterate on the project in light of the testing, how the testing results turned out. Okay. Stuff always takes way longer than you think it's going to take. So where possible, you will probably want to make the timeline a little bit more ambitious than you think will be necessary in order to get stuff done in time and leave lots of time at the end to finalize, polish, make sure that you don't miss out on a project where you did like 90% of the work, but because you didn't have enough time to do that final 10% because things went wrong, now it looks like it's only 50% as good as if you had that extra bit of time, right? So one thing in doing time estimates that a BIMR technician and friend, Jim Garrett, said is always, when he's coming up with time estimates, he takes how long he thinks it's going to take, and then he multiplies it by 4, multiplies it by 2 for all the issues that he sees that could go wrong, and multiplies by another 2 for all the things that could go wrong that he doesn't anticipate yet. So I've tried this, and when I do it usually is pretty accurate for how long things actually take. All right, now in terms of actual assessment, 50% of the grade comes from schedule-driven grading, which actually refer to all these things that are due throughout the course, and we'll talk about how those are marked in a moment. The other 50% come from the judge's evaluation at the Expo. Let's talk about that. So the judge evaluation is going to be based on a rubric, which is going to be this rubric or substantially similar to this rubric, which is shared across departments and evaluates you on a number of criteria. So they're going to be asked to evaluate your originality, the presentation, whether it was organized, whether you knew what you were talking about, the visual impact of your project, the illustrative material, the demonstration of the results, and the clarity of it. And then the technical content. How complex was it? Is it really university level? Is it, what's your analytical competence in here? So your quantitative approach, use of calculus, numerical calculations, plotting and graphing, how complex the design was, the depth and breadth of the design abstraction and creativity of the solution, the functionality, like how well it looks like it works, the results of testing, reliability, portability, etc. And then perhaps most importantly, overall impression, considering all the aspects of the project, that is the importance and clarity of the thing you're going for, what you're trying to do, the creativity, applicability, and success of the solution you came up with, and the quality and quantity of the engineering that you did to achieve it. The judge is going to be asked to rate the overall quality of this engineering capstone project as presented. Then they're going to be asked to evaluate the independent learning. So, did you end up below, marginal, meets, or exceeds at your ability to be able to critically evaluate and apply knowledge, methods, and skills procured through self-directed and self-identified sources, including those that lie outside of the normal course curriculum. This is this lifelong learning. Be a person that recognizes when you need to seek external information and then goes and gets it on your own initiative. So depending on the project, you may take more or less time on the various stages of this. As we said, some projects could have more mathematical modeling and less physical assembly. The Expo itself is due on Thursday, April 8th. Well, I should say it is. It's not due at this time. It is on this date. The deliverables, the final report and the video are going to be due a few days before. I think, yeah, so the Expo is on the Thursday, and the final deliverables are due on the Monday of that week, which is April 5th, right? Yeah, April 5th. Right, I also have that written down, actually. So Monday, April 5th, when the project is due. This means the Expo deliverables are due on this day, while the Expo itself is on Thursday the 8th. Okay, next up, let's go and talk about these weekly deliverables. So this is discussing the things that are due every week here. So the 3 things that are due on most weeks: the drafts, reviews, and then either PSR or ITP metrics, peer assessment. And these are the things that make up the other 50% besides the industry judging at the Expo. Oh, I should say that in rare circumstances, we reserve the right to change the industry judges assessment. So if for whatever reason your project just didn't come across clearly to the judges, but we know that you did a fantastic job, then we reserve the right to adjust this. Okay, so weekly deliverables. The idea behind the weekly deliverables comes from this influential Medium post by Patrick Watson about how to teach without a classroom. The idea is we're going to use this schedule-driven grading idea. So in Capstone, we have to hand in a whole bunch of things along the way, but what we really care about is that the final project looks amazing. So all of the things along the way, it's okay if your first draft of it is bad, as long as we get to that good thing at the end. So because of that, the grading for these is just, did you try, right? Like, did you hand in something by the right deadline and put in a reasonable amount of effort? And that's what we're going for. This works because the whole course is set up already around prep work and portfolio work. These are like little bits of steps that you make towards progress and learning, and then something that you're planning to show to an employer, your Capstone project, right? That you're going to show off and say, hey, here's this cool thing that I did that shows the skills that I can do in engineering, and therefore that's why I would be an asset to this particular company or research group or wherever it is, maybe venture capital, whatever it is that you're going for in the future. So there's a lot of feedback that goes on in this. And I want to emphasize being constructive in this process. So instead of saying this sucks, say like, when you do X, I feel Y about it, and could you try Z instead? And to help you be constructive, I will say that you want to be aware of the fundamental attribution error. This is a social psychology effect that is that when you see yourself do something, you're very inclined to say it's because of the situation I was in. While if you see somebody else do something, you're very inclined to say, oh, that tells me about who they are as a person, without attributing it to the situation they were in as well. Now, in reality, the situation has a huge effect, right? Like, check out this Veritasium video for more information on it. You don't know about other people's situations, so really don't judge them if they miss a deadline or turn in work that's not so great. If you were in their situation, you would have done the same thing. So instead, just do what you can to help them improve their situation. For your own sake, for your own self, the Veritasium video also goes over the fact that you want to act as if success is the result of hard work, but be aware that there's a whole bunch of randomness and situational effects in there. Yeah, be aware of that. On the acting like success is hard work, one thing I'll add to that is the idea of internal locus of control. Focus on what you can do something about, even though it is true. And we've got to know that it's true that a lot of success and whether you're successful is going to come down to situational things and luck that you don't have control over. Don't put your attention on those things. Put your attention on the things you do have control over, right? So focus on whether you work right now on something that's going to help you become more successful. That's what you worry about. That's because that's what you can do something about. That's where you can make progress. But again, as the Veritasium video points out, be aware that even if you do everything right, it doesn't mean that you're going to be in the best situation, because there's a lot of luck that's involved in it. So you're never going to be in a position to really judge somebody or say that their project was not successful, therefore that's about who they are as a person. No. It's that there's so much external, so much of an effect that is played by external factors that it's pointless to go and judge people or even judge yourself for the results of this. So focus on what you can control to make progress and improve. Don't be judging people, and don't take too much credit or blame for yourself. Take responsibility for your own things, right? Like do what you can to do that, but don't blame other people for the situation that they're in. Now that that's all done, in engineering, we've got to separate ourselves from our work, and the situational knowledge about that, the knowledge that your situation is very much due to luck a lot of the time. Then with that in mind, you can step back from it and say, okay, I'm not my work. So if somebody says that this calculation is wrong, they're not making a comment on who I am as a person. They're helping me, right? They're saying the calculation is wrong just because, the calculation's wrong. That past me made some mistake in that thing. Oh, well, let's fix it, right? Let's get it done. This is a hugely important attitude to have in engineering, that it's good if somebody points out a mistake you made. Because what do you want? You want them to not tell you about this mistake that you made, so that now the plane is going to crash or something? Definitely not. You got to know, right? You thank that person for pointing out some mistake that you made. People are all right. We're all going to do that. We're a good community, and everyone's going to be aware and of the fact that you're not your work. It's okay if something is not good, and if somebody tells you a way that it could be fixed or improved or a correction to make, that's a good thing. You're not causing somebody to lose marks if you point out that something they did was incorrect or it could be improved in a certain way. You're only helping them if you do that. Okay. So how specifically are you going to do that? Well, informally, whenever you like. If you're looking at somebody else's work, then you can help by making corrections to it if you're so inclined. But formally, every Monday, you're going to hand in a next draft of whatever project deliverable or subcomponent or anything towards these project pieces you personally have been working on and want to get feedback on. Then Wednesday, you're going to be paired up before this, like shortly after the Monday hand in there. On Wednesday, you hand in a review of somebody else's draft. So you get paired up with somebody who likely is in a different project, and then you hand in a review of the draft that they put in. Review with suggestions for improvements. How can they make it better? Again, it's not about them as a person, so be honest. And if you find 500 mistakes with it, you're not going to be causing them to lose marks, right? Like they get whatever mark they get on this Monday one, which likely is 100%. We'll come back to that in a moment. So then next draft on Monday, Wednesday, a review of somebody else's next draft. And then Friday alternates between project status update, like a PSR, project status report, or the peer assessment. So how do the marks work for this? You start at 100% in each category. In this category, I should say, like the thing that is worth 50%, these weekly deliverables, 50% of your final grade, you start at 100%, meaning at 50%, right? But a mark of 100% on this 50% grade thing. And then you lose 3% for every of the 100, or 1.5 of the 50, for every time you miss something. After one automatic freebie. You get one automatic freebie, and then you get reduced by 3% every time you miss something. Now, what does missed mean? Miss means you hand in something, you don't hand in something by the deadline, right? So Monday comes around and you don't submit anything. Okay, well, that means you missed it. What else could it mean? It could mean that you handed in something which is like a blank document, or really not a fair effort, a reasonable effort of making progress on this thing. So on the review, you just sort of said, looks good. Didn't do a serious review, didn't put in a reasonable amount of effort to give the amount of suggestions that we'd expect as your work in this course. So put in something which is an honest try towards these deliverables, and you'll be fine. You'll get the 100%, you're good. What's an exception? So exception is this one, which is on the lateness one. So there is a way to get marks back if you lost them for submitting something late. So if you use an MSAF, then what it does is it delays the deliverable due date by 3 days for you. So this is only applicable to the individual deliverables. The group deliverables, which is when the project is due, and the Expo cannot be MSAF'd because those are specific, like final exam type major deliverable things at the end. But anything else you could use an MSAF on, and then it delays it by delays when it's due by 3 days. So you could then hand it in later without penalty. Okay. Another thing you can do is if you end up submitting something late, then you could just hand in the next 3 deliverables 3 times as early. So imagine that there's something goes wrong with your router at the last minute. You put it off to the last minute, first of all, and then you hand it in 10 minutes late. So that is an issue. To help get around it and prevent it from happening in the future, so you have a couple of options. You can just say, all right, well, I'm going to take the grade deduction. It's not the end of the world. We have some freebies anyway. Stuff happens. Or you can hand in the next 3 deliverables at least 3 times as early. So if you were 10 minutes late, then you can be at least 30 minutes early on the next 3 deliverables. And if you do this and you take the right screenshots and send it to your TA, the onus is on you to demonstrate this if you want to take advantage of this option. Then we'll forgive the time that you were 10 minutes late or whatever it was that on that first deliverable. So that's one exception. You can, it's not free. It's hard to do this and make up for it. But it is one thing to get around a last minute crazy thing that happened and encourage you to not leave it to the last minute on future deliverables. And the other exception is if you go above and beyond and submit truly outstanding work on a deliverable, we reserve the right to return marks that you lost on earlier deliverables. It's possible that this will happen if you hand in truly outstanding work on things in the future. So some things to point out are that these marks are all pass-fail, right? It's not, you don't lose marks for not being on track with the project status updates, and you don't lose marks if your peers say that you did less work than them on the peer assessment. These don't affect marks, right? It's important that you're honest with these, and we think that by making them not affect your marks is going to be a way to encourage you to be more honest. So for the project status, if you're behind track, that's not a problem for marks. It might lead to a problem for marks if it means your project is not done at the end. So for us to be able to help you, we need you to be honest with it. So you will ideally use some kind of a Gantt chart to show where you are with respect to being on track or not, and keep this up to date and talk about it in the project status report. Then your TA will be able to know where the project really is and give you feedback on that. So it's all about honesty. It's not about just making it look like you're in better shape than you really are. You've got to be honest about where you are with this so that we can help you along with it. And same thing with the peer assessment. The peer assessment is not there to throw your team members under the bus or take their marks away from them or something. It's to encourage everyone to try, prevent people from not contributing fairly and leaving everything to their group, and to help find out where you could improve yourself by getting honest feedback. So these depend on honesty, and honesty again is impaired if the marks would be damaged. So these are not tied to marks. Instead, they're just used as a starting point for a conversation. So if your group has somebody which is at at a very low assessment compared by their peers, then this is something where the TA in the monthly one-on-one meetings will be able to talk and say, hey, what's going on? How can we help? What can we do to improve things? Yeah. Now, in urgent situations, even though you have, let's talk about these meetings, by the way. You're responsible for scheduling regular meetings or correspondence with your client and TA throughout this process. So you're going to want bi-weekly correspondence with your client as a group to prep for PSRs, and bi-weekly correspondence with your TA as a group to take up the PSRs. These are not necessarily meetings. The TAs and hopefully the clients will be available for meetings, but you at least need a correspondence in a documented way to discuss what's going on and where you're at with the group. So what definitely are meetings are the monthly one-on-one meetings with your TA to discuss the project and address any group dynamic issues or concerns. These are very short. These could just be 5-minute meetings each, and it could be that everything's fine and we're just moving along, but you do have this explicit time to talk to the TA once a month here to point out anything that you think you could use help with. Now, in urgent situations, despite the fact that these things are that you have to have these things at least on this schedule, in urgent situations, please feel free to schedule additional meetings or reach out in the forum, however it is you feel is the fastest or would help the best, with your TA, instructor, or your client to address any of these points. On the meetings, besides things that are of a personal nature, when you have a meeting with your TA or your client, you should be taking minutes for these meetings, and then posting the minutes in whatever forum is appropriate for this. So if it was general course feedback or course questions about how the structure works, then you're going to want to post those minutes in the general course place. If it is stuff that is specific to your team dynamics, perhaps, and not something we want to involve the whole course in, then you could post that in your private team channel within the course. But technical things, even if it is technical things specific to your team, generally should be available for the rest of the course too. And this is to go in the plan of having this very open course. So everything's welcome. One of the things in this David Kellerman video that I really like is that we have to have the course forum be the real forum. And to do that, we've got to make sure that everything is allowed, everything that meets the student code of conduct. So anything that's not illegal or against the student or committing harassment is totally fine here. So if you have old final reports, if you have other solutions or code from past students, then post it. That's all okay. There's a spot for memes, because I know some of you just like have to have that spot, and it's there, right? If you find a video of somebody explaining something better than I did, then don't keep it to yourself. Share it, right? Everything is okay in the forum. So this is important to help keep it a real forum and a place to collaborate and help each other to make this a more successful course. Okay, next up is the idea of bonus deliverables. So there's some optional things that you could and should consider in the course that will be big boosts to your portfolio for the purpose of getting a job, and definitely good ways to make yourself score better with the industry judges at the end of the year. Examples are being a finalist or winner of external design competitions, writing and publishing journal articles of optimizations or extensive simulations, etc. in the course of your design, filing provisional patents, or securing industry funding or partnerships or other investors for your projects. Besides the intangible benefits of making your project look a lot better at the end of the year, and as you move beyond and apply for jobs, and the tangible benefits of these in terms of the prize and startup money, etc. These are great examples of places where you can go above and beyond and get get marks back that you may have lost on earlier weekly deliverables that didn't go so well for you. Sometimes life gets in the way, and it's not the end of the world. You can you have this as an option as well to help overcome that. Okay, accreditation learning outcomes. There are a lot of accreditation learning outcomes. There's lots of things that that the course is going to help you to do, which is going to demonstrate to the CEAB that you have skills towards the various attributes that we hope that a graduate of an engineering program will have, and these things that indicate that you have competence towards those attributes. Okay, so that is the main set of things that are specific to 4A06 that I wanted to go over in this talk. There's lots of other details that are laid out in the course forum, and definitely that should be the main place to be asking for clarifications or follow-ups, because if it's just in an email to me, then not everybody will be able to benefit from that answer. And I want to make sure that we have this open communication and keep everything going on and keep everything as helpful as possible for everyone. So the forum is the main source for where we're going to be communicating. In the forum, a few places to draw your attention to right now: the surveys, which are self-reflection surveys. That's in the course outline. We have these, you may remember, S1, S2 at the midpoint, and S3 at the end, self-reflection surveys. Those are available in the forum under assignments on the general tab. So on the team for ENGPHYS 4A06, go to the general tab, go to assignments, and then you'll find them there. They're also just linked here in the general tab as a post itself. So go to that, and that will take you to the survey, which is the first thing due on Friday, September 11th. The other things besides the surveys are all going to be submitted as replies in this work submissions section. So this is where you're going to be handing in your individual deliverables. That is as a reply to a post that I'm going to put each time. For each deliverable, you reply to that with the format that's laid out up on the top here. So you're going to have like your group number, which may be G1, G2. You'll know what that is after you've formed the group and I've given you your own private channel, like for these groups here. Then you're going to have the date that the deliverable is due. So the first one like this is due on the 14th. The survey is on the 11th, but then the first deliverable like this is the 14th, and it is a draft. And then you put your Mac ID, and then you say a description that's up to you. So maybe like my proposal for a waffle engine or something is going to be here. You submit it in PDF format. This is very important. The main thing that you submit is PDF format. You can put optional additional files if it makes sense or is helpful for whoever is going to be looking at this or reviewing it. You can add those, but the main deliverable is PDF format with this file name. That's going to make it easier, way easier for everybody to sort through it and for you to find the draft that you're going to be reviewing. So then, the next one on the Wednesday that week, you would submit your review of somebody else's draft, put your name still, and then just up here say review of Garrick's cat gun proposal or something, whatever it is that you're reviewing. And then the PSR on the Friday, you would submit similarly, and just give it whatever thing, like this group project status report number 1. Yeah. Okay. The only exception to this is the ITP metrics. There's going to be a special post in the forum about where you go to do those. That peer assessment is on an external site, ITP metrics likely. And we'll explain how that works in the forum. That's not due until the Friday after this. The first one's on the 25th. So we have a little bit of time, but keep your eye on the forum for how that will be explained. Other things in the forum, we have a place to ask questions. We have a place for memes, as mentioned, a place to put any tips or resources that you have. And we talked about the assignment thing. But if there's other things that we need besides the personal team space, if there's other channels that we could use here, let me know and I can make them. I'd be happy to make other channels for like, maybe we'll end up having like a cross group sub channel thing here on specific areas of interest. Like if a bunch of groups end up doing things with image processing, maybe we have a channel here for image processing, like sub team or something, and that's where you would get together for that. Maybe we need an informal space, like a hang out in the Capstone room channel, which is going to be mostly for people to just meet informally and talk about how the project is going across groups. Yeah, so if you have suggestions for these, then let me know and I can make them. And that leads me into the last point that I wanted to talk about, which is the idea that this is a learning process for me too. So almost any intervention that you can do looks like it increases learning. If you take a class without homework and you add it, people learn better. If you take a class with homework and you take it away, people learn better. And this, it seems like the reason is that just studying how much something has improved learning increases learning, because the thought is you get teachers asking the question of how well students are learning, and you get students asking themselves the question and telling the teacher how well they are learning. So think about how well this is working for you, what's effective, what's not, and then let me know. And we can work towards making the course better all the time and a better learning experience for you. I'll post some links to some other Capstone resources. There's the Capstone project gallery, the past projects in the ENGPHYS Capstone course, virtual expo from last year to see what it looked like at the end. Our expo is going to be more of a virtual trade show format that's a lot more involved than this one, where you have your final report and video submitted and you have an opportunity to meet with the industry judges. Then some external things. This is an MIT Aero Astro Capstone video that shows how it works there for some inspiration, and maybe to get your competitive spirit up. If competing with computing and software or ECE doesn't do it for you, then here's Waterloo Mechatronics' Capstone video. So check that out to get fired up. You guys are absolutely as good as them, and I have complete faith that you can do it. So and the final ones are some CHCH news postings from past ENGPHYS Capstone Expos in 2016 and 2019 when the news showed up and featured us. So thanks for watching, and see you in the forum.